Okay, so in this video, I'm going to go over section 3.3, which is making predictions from a least squares regression line. So what we're working with is technology output. So we aren't actually finding these lines yet. We're working with a diagram in the lines or just output from someone finding the line using data. So we're working specifically with the linear regression line, and so that line is expressed as y hat equals bx plus a, where y hat is the predicted value of the response variable, x is the explanatory variable, b is the slope, and a is the y-intercept. So I'm going to go over a variety of information using one of the scatter plots from I pulled this either from the assignment or from the notes. I think I pulled it from the assignment, and I'm just asking different questions about it. So the scatter plot is used to predict, the scatter plot shown is used to predict when the next eruption event will happen for Old Faithful. And so the x-axis or the explanatory variable is the time of the event in minutes. So this is how long the eruption lasts. And then the response variable is the time between events. So how much time until the next eruption will happen. And so they inputted the data into something and got the equation y hat equals 30.33 plus 11.44x. And so what we're going to go through first is just identifying the slope and the y-intercept and interpreting that in the context of the problem. So looking at what that means in terms of the geyser. So the slope, remember, is the b value. The b value is attached to x. So that means that the slope here is positive 11.44. Remember, if we think about slope as rise over run, this number has to do with the y variable, and this number has to do with the x variable. So the change in y over the change in x. And so what this means is that for every 1 minute that the geyser erupts, there will be 11.44 minutes until the next eruption. Remember that we're always going to turn that into a fraction over 1. That 1's always going to represent the explanatory variable. So for every 1, whatever the units are for the explanatory variable, there will be however many units of the response variable. So for this one, for every 1 minute that the geyser erupts, there will be 11.44 minutes until the next eruption. Okay, the next thing they want us to identify is the y-intercept value as the constant, so that's 30.33. Remember that the y-intercept means that means in the context of this, it lasts only 0 minutes. The next eruption will occur in 30.3 minutes. However, if something doesn't take place, it lasts 0 minutes, then I can't predict the next one. So this doesn't make sense. In this problem. So that means that we won't have a value where x is 0. Notice that here the data values are all between 1.5 and 5, right? And so that won't have a y-intercept. The line only goes through the points. And so we can't expect it to actually have a y-intercept. However, they're saying, like, if the line were to continue, right, it would cross it at 30. C is now asking us, so if the duration of a future eruption event is 150 seconds, guests can expect the next event to happen in approximately what? Okay, so the duration of an event is which variable? So duration of the future eruption represents the time of the event, not the time between events. So that means that this is an X value. One thing to notice though is that our units here are minutes. So we're given X in seconds. So what we have to do then is to figure out how many minutes this is. So if I know that there are 60 seconds in a minute, then if I divide this by 60, that'll tell me that X is approximately 2.5 minutes. So in order to find the time between the events, right, when I can expect the next event to happen, I'm going to use the predicted value formula. So I've got y hat equals 30.33 plus 11.44 times my 2.5. And that's going to tell me how many minutes in which the next event's going to happen. So if I do that, I'm going to get approximately 58.93 minutes. So it's going to take about an hour for that next eruption to happen if the previous one lasted for 2.5 minutes. So then for D, they want us to know if the time between events was 1.5 hours, what was the approximate length of the previous event? So this is backwards. So they're giving us Y hat. So I have the time between events was 1.5 hours. If we go back and look at our information, time between events should be in minutes. So that means that we have to convert it to minutes. So since we know that there are 60 minutes in an hour, we're going to do 1.5 times 60, which means that we're going to have 90 minutes between two events. So what happens then is if I plug into the equation, I'm now plugging in Y hat. So 90 equals 30.33 plus that 11.44 times X. So what I want to do then is subtract those values so that I can get X by itself. So I'm just solving this simple linear equation. So if I subtract 30.33 from both sides, that's going to leave me with 59.67 is equal to 11.44x. Then if I divide both sides by 11.44, that's going to give me that x is equal to 5.22. I'm going to round. Okay, so that means that the previous event was approximately 5.22 minutes. Okay, so then the last thing they're asking us about is which predicted value would be more accurate. So if X is 3.5 minutes or if X is 10 minutes. So let's go back and look at our data. So remember that our scatter plot goes from about 1.5 to 5. So an X value that fits between that range is going to be more accurate than a value that's outside of that. So the domain of our scatter plot starts at about 1.5 and ends at 5. If I end up with an X value outside of that domain, then it's going to be less reliable than a value inside that domain. And that's that word extrapolation, right? So we're going to say that x equals 3.5 minutes because the value lies within the domain of our scatter plot. Okay, so what this is regarding is our confidence level in the output value, in our predicted value. So I'm highly confident in my answer if my x value is in the domain. So I'm confident that I can predict the number of minutes between two events if my x value is 3.5. Excuse me. If my x value is 10, it's outside that domain. So I have a low confidence in the answer, right? I can find the answer because I can plug 10 into my equation, but I have a low level of confidence in that value for 10. That's because of extrapolation, right? So because it's outside of that domain, I'm extrapolating. I don't have data to support that that happens past that number of minutes, past 5 minutes. Okay, so that's all with 3.3. Again, it's a lot of just doing some algebra with these values and reminding ourselves about the parts of linear functions, and then understanding what extrapolation is and how I can be more confident about my predictions based on given a range of values within our scatter